Hello, hello. It's very lovely to be here. So lots of people, excellent. Yeah, I'm Claire. I think it's polite to try and speak the local language, so please excuse me while I mangle a piece of Turkish. Merhaba? Did I get that right? There's some smart, yay, hey, okay, cool. Yeah, I'm Claire. I suppose I describe myself as a UX strategist these days. The boundaries between UX and product are a little bit fuzzy. I'm kind of in that fuzzy bit. And yes, I'm the lead author of this book, and I have some to give away at the end. So I hope, many of you using Twitter today? Have we got a few hands? Okay, I was going to do it that way, so I hope that works for people. So how many of you work on software products and services, web stuff? I'm expecting lots of hands. Okay, that's quite a lot of hands. Good. How many of you work on products or services which have some kind of physical electronic hardware component, sensors, actuators? Oh, good, excellent, good few hands. How many of you own a connected product, an Internet of Things thing, or use one in your everyday life? Okay, also lots of hands, that's great. And how many of you would like to work on connected products? Also good few hands. Excellent, fantastic. Okay, so I'd like to start with a quote from by an analyst called Benedict Evans, who works for Andreessen Horowitz. He's very smart. It's worth reading his blog if you haven't seen it before. And he said, I really like this because this for me kind of sums up what's creeping up on us, if you like. He said, my grandfather could probably have told you how many electric motors he owned. There was one in the car, one in the fridge, one in his drill, and so on. My father, when I was a child, might have struggled to list all the motors he owned, how many exactly are in a car, but could have told you how many devices were in the house that had a chip in. Today, I have no idea how many devices I own with a chip in, but I could tell you how many have a network connection. And I doubt my children will know that in their turn. Now we often talk about IoT as shiny, kind of exciting, innovative things, and maybe it's a bit like magic. Some people like to talk about designing for it like magic. But what this sums up for me, I think, is the idea that something is happening, and very soon it's just going to feel normal. Because although we sometimes, particularly in the consumer space, say, does this thing really need to be connected? Do people really need that? It's becoming so cheap to do that, and so easy, at least, to make it technically work in many respects, that this is kind of happening anyway. And I think, like electricity, which people used to think was magic when we first had widespread access to it in the home, which was then became to feel normal, and I think that's going to happen with connected products. Now, when people talk about and write about connected products or IoT, there's very often the press, in particular, love to accompany those things with pictures that look a bit like this. Everything is very shiny, and there's a fridge in the middle of it because the internet fridge is a massive cliche. And all of these things are kind of seamlessly anticipating your needs and coordinating to deliver stuff for you. But the reality is not really quite there yet. And this relates to some technical challenges, but also to some challenges that designers who work in this space need to deal with. This is a real quote from a review of the Wink home automation system, which was an American system that no longer exists because not enough people bought it. What this review said, it was largely very, very positive. And the person was very excited that they could turn lights on and off from a smartphone app. But then they said, it's a bit glitchy, meaning that sometimes the phone app will tell you that the lights are actually on when they're off, and sometimes it will tell you that they're off when they're actually on. But that's fine, because you're in the room and you can see what it's doing. Can anyone spot a problem with that? So, if you want to make a really rubbish light switch, you don't need to use the internet, okay? You can just make a rubbish light switch. There is no point putting the internet in something. Well, there is sometimes, but if it's always going to be used in the same room, maybe that's not the best way to do it. And so I think that by putting new functionality in things, we also potentially create new ways for those things to fail, and we have to be really smart about that. And this relates to some of the challenges I'm going to talk about today that designers need to think about. And of course, it's a bit frustrating if your light switch, your smartphone app controls the lights, maybe doesn't work very well, but it's not perhaps a disaster. But in some of the other applications and use cases that which we're using connected products, things like monitoring whether a baby is breathing or not, okay, if you're diabetic, monitoring your blood glucose levels, or controlling things like front door locks, or even you can park your Tesla from an Apple Watch. I don't have a Tesla, but it's like you can control a car from a watch. That's quite cool. But if those things are glitchy, all of those things could have quite serious and potentially even dangerous consequences. So there are still some technical challenges in getting this stuff right, and some work that designers who work in this area have to do to kind of manage people's understanding of what's happening and set the right expectations. Now, the stuff I'm going to talk about today is really, people often think if you're a designer working in connected products that you must be involved in designing hardware. Now, I'm not. I'm entirely from a software background. I once designed a UI for a physical thermostat, but that's about as far as it goes. I will talk quite a lot about thermostats today, so please excuse that. It's a bit of a connected product cliche, but I have actually worked on them quite a lot. And I think one of the things I wanted to get across is that even if you are from a software background, actually you don't necessarily need to learn about electronics or need to be trained as an industrial designer in order to work on connected products and in order to work in IoT. There's lots and lots of big part of the UX is actually about stitching things together with software. And there are some special things that software designers need to think about, which are in working in connected products, which are different to working with software-only services. And now, when we talk about design for IoT, typically people kind of think about one of two things, perhaps. And one of those might be the hardware. The Nest thermostat was one of the first examples of a kind of mass market-ish physical, nicely designed, connected product that became a bit of became a sort of iconic thing. There's also the smartphone apps, or sometimes web apps that we use to control those things. This here is the Philips Hue, a screenshot of the Philips Hue app. And then there are some novel UIs which are becoming, people are beginning to take a lot more interest in. So things that are perhaps not conventionally a visual UI. And one of the big examples of those now is obviously the Amazon Echo with a voice assistant called Alexa. You can only get this in the US at the moment, so I'm kind of desperate to get my hands on one. But this is, you can talk to Alexa and get her to control various connected devices that you may have around the house. So that's all very exciting. But the thing is that it's possible to do a good job of designing the hardware and a really good job of designing an app in isolation, but for the user experience of the whole system not actually to be very good, or to kind of fail in some ways. And that's because we can't really think about, connected products are systems of networked things, and of UIs, and of web services. And in order to create a really good experience, all of those parts have to work together. So you can't just go off and make a UI for the phone UI, and then some other people elsewhere are working on the device, and you don't talk to each other. Because the result you get from that probably won't hang together. And I'll show you some examples of some of the things we need to think about. So what this boils down to is that really designers need to think about the whole system and aiming to create a coherent UX in which all of those parts work together. And I haven't got very long today, but I'm going to try and give you a flavor of what some of those challenges are that you need to think about when you're working on the system. And the first one of those, really, is just deciding which bit of the system is going to do what in terms of user-facing functionality. And the one term that I would use for this is composition. So these two things here, you can't see the white on white very well, I'm afraid. These are both thermostats. I don't know whether you're familiar with either of these. These are connected thermostats, and the designers of each system have made quite different decisions about how much functionality they're going to handle on, how many user interactions they're going to handle on different devices. So the one on your left is a TADO. This is a German system. The designers of the TADO basically decided that they would do very little on the physical hardware itself. So the current version will actually tell you what the current temperature is. That's about it. If you want to do anything else, you have to use the smartphone app. And that's quite an elegant solution in some respects, because it's kept the cost of manufacturing the hardware as low as possible. And it means that if you want to iterate that UI over time, or you want to add new features, it's much easier to change a software UI than it is to change a hardware UI. You can't change physical buttons that people have on devices. The other example is the Ecobee. This is probably a more expensive piece of kit. And the Ecobee designers have basically decided that you needed to be able to do pretty much everything on all of the devices. So this has resulted in something that's probably a more expensive piece of hardware, and it's much harder to change how it works over time. But it also means that if you're in a house where you don't have access to the smartphone app, or you've lost your phone, you can still, in your cold or your hot, you can still control the temperature. One of the other really challenging things about working with systems of different devices is understanding how when everything works, everything is connected, and that's fine, and you don't really have to worry exactly about which bit's doing what. But when you have lots of different parts, things will sometimes lose power, and things will sometimes lose connectivity, because this is the nature of networks. And when they do, that has different consequences for how things fail. So, and this is not just something that designers have to cope with. This is something that users are going to have to start getting their heads around as well, which I think is going to be a really big challenge. Now, to give you an example, take connected lighting. It's very common for connected lighting systems. The example here is a Philips Hue again. It's very common for those systems to have automated rules. So you can say, for example, at 8 p.m., I want to turn some lights on in my house if I'm not home to make it look occupied. So that people don't break in, hopefully. Now, those rules may run in different places. Essentially, this is about where the code's running. Now, for some systems, the rules will run in the cloud. And some systems, they might run in the cloud, but they might also be mirrored on a local device called a hub. So it all depends on how the light bulb connects, if it's a light bulb. So now, this matters because if your home internet connection goes down, you want to know whether your rules are still going to run. Now, if the rules run in the cloud can't get that message, and the internet connection goes down at 7:59, the cloud can't get that message through to the lights at 8 o'clock. So basically, nothing's going to happen. If the rules are also running in the hub, if you have a hub, not all systems do, then at 8 o'clock, the internet connection's down, but it's OK because the hub can still tell the lights to turn on. You, as a user, if you're somewhere else, can't actually see that that's happened, but that's going to happen. And so there are all kinds of different systems out there, and they all work in slightly different ways, and they connect in different ways. And when everything's working fine, it doesn't matter to the user where things run. But inevitably, things will go wrong. And as a user, you need to know exactly how. So then there are some more kind of UI-centric things. And one of the big challenges if you're working with systems of things is you may have different devices that have different forms. You may have UIs that run on browsers, that run on smartphone apps, that run on watches even. And you've got to try and make those things somehow feel like a family. You've got to allow people to sort of transfer learnings that they've got from one device over onto the others. And there's lots of stuff here. But the most important one, which will sound really obvious, but actually isn't always applied very well, is terminology. So if you've got a function on one device and it's got a particular name, like, for example, a manual setting on a thermostat. This one is a British Gas Hive. I worked on a predecessor to this. So this is manual, and it's manual on the device and on the phone. Now, there was an earlier version of this product where somebody had the bright idea that although a thermostat was already in existence that said auto for the opposite function, that schedule was a better word. So they changed the word in the smartphone app. So you had the same function with different names on different devices. And because users find thermostats a bit scary and confusing anyway, nobody knew that they were doing the same thing. So that's kind of, easy but obvious. So the second thing is really that there are more kind of aesthetic things to do with consistency, to make the system hang together as a family. And Nest are pretty good at this. So there are some obvious visual similarities between the smartphone app and the thermostat itself. But there's a nice subtle little thing they do as well. So when you adjust the temperature on the thermostat, it makes you rotate a bezel and it makes a little clicking noise. And when you tap the up and down arrows on the phone, because you don't want that kind of interaction on a phone, so this interaction is much better for small adjustments, it makes the same clicking noise, which makes the things sort of feel like they're all part of the same family in a nice way. And then some of the other big challenges come from the fact that people just have different expectations of the physical world than they do of the internet. We don't expect things to start exhibiting internet-like behaviors. Now, when we use the web or the internet, we experience some of the glitches. We experience sometimes that web pages are slow to load, emails are slow to download, files are slow to download, Skype calls can fail. These are properties of the network, essentially. There's latency and there's reliability. But our expectation of the physical world is that if you go to open a door, the door opens right away. If you turn a light on, the light comes on right away. It doesn't take 30 seconds for those things to respond to you. And they don't sort of magically just kind of not work at random because, I've lost your instruction. But when you put those kinds of network behaviors into physical things, they just feel really broken sometimes. I'd like to show you a little video.
So we're on the Wi-Fi.
This is actually me turning my lights on over a local Wi-Fi network. So that was pretty quick.
It all works beautifully. Turn it off.
That was quick.
And now what I'm going to do is turn off the Wi-Fi on my phone.
Disconnect from the Wi-Fi.
Switch to mobile network, which forces this to go over the internet.
Over the internet.
Mm-hmm. So much slower.
No.
Not worked at all. Come on.
Hey. Okay.
Oh, it's so much slower, isn't it?
So as you can see, it's not massively dramatic, but when I forced that interaction to go over the internet, it might have been routed halfway around the world, and it took a little bit longer. It wasn't, hugely long, but it did take a few more seconds, and that delay could be anything from a few seconds to quite a lot of seconds. And that's not, so sometimes, the point is that sometimes things don't happen straight away over the network. And one of the other challenges that we experience in working with connected products is about intermittent connectivity. So when we're used to working with laptops, with desktops, even with mobile devices, connectivity is the kind of normal state. The things are connected. Sometimes they lose connectivity, but we're able to treat that as designers as a kind of edge state, as a kind of error state. Many connected devices actually spend most of their lives not connected, because lots of things run on batteries. Now, in the UK, it's pretty common for thermostats to run on batteries. I'm not sure how that works here. And maintaining an open network connection takes a lot of power. So basically, if you've got a battery-powered thing that has to stay connected all the time, particularly if it's using something like Wi-Fi, you'll burn the battery really quickly. So a lot of these devices will stay offline most of the time and check into the network occasionally just to see if there are any new instructions, or perhaps when they have some interesting data that they need to send. And what that means is that if you've got displays on some of them, you will notice as a user that the things sometimes get out of sync. So, for example, this is an older Hive. This is a thermostat I have at home. It only checks into the network every 90 seconds to see if there are any new instructions. So if you change your heating or cooling setting, we don't have cooling in the UK, it's freezing. But if I change my heating setting, it might take 90 seconds or even longer for that change to be represented on the thermostat. Now, in that time, I've got two UIs giving me different information about the status of the system. And that breaks a really fundamental usability heuristic that you should always be able to see what the system is doing. So that kind of creates interesting challenges for design as well. And the challenge here is really that, this idea that this direct manipulation, paradigm that we've been basing, the last 30 years or so of human-computer interaction and UX design on, is really, it's like things aren't going to work like that anymore if they're connected. The idea that when you press a button on a UI and it shows that it confirms that you've pressed it, and it also shows you that the action you wanted to happen, oh, hello, I've been cut off. I've only got about 2 more. Oh, sorry. There we go. Green. OK. Oh. You can see that one, can't you? OK. So the idea that both confirming the state and also, am I being cut? Sorry. Yeah, I'm winding up. All right. The idea that confirming the state and also showing the, I've got no slides though, so OK. Sorry. All right. Essentially, we can't create these kind of seamless experiences in IoT. There may be delays between something happening and between the response to the thing happening, and we need to handle those gracefully. And I wanted to show you a couple of quick examples of those. I'm not going to be able to do that. But essentially, what it boils down to is you can either lie to the user and pretend that the thing they wanted to do has worked, and then just show them an error message if it hasn't. Or you can be really honest about what's actually happening on the network. And you can say, all right, I know you've pressed the button. This little indicator up here this is a system called Iris. It says when you press a button to change a setting, it says, sending changes, please don't exit. And everyone stands there and you can't touch anything. And then it will confirm once it's done it. So it's all about handling interstitial states, essentially. And depending on the context of what you're doing, sometimes although this is a bit clunky, sometimes you actually need to do this kind of stuff. And in summary, I would say that this is a model that's used in the book, that when you're designing for connected products, it's not just about the visible parts of the system anymore. One of the things that's really interesting about this is the complexity. So the parts the user might see might be the UI and the interaction design and the industrial design. There's a whole lot of stuff around interactions spanning multiple devices, interusability, and a conceptual model, how do people actually understand which bit's doing what, as well as commercial and technology enablers that you need to understand and you need to take into account. I'm going to try and get this right again. Teşekkür ederim. Oh, yay. Thank you. I just wanted to say that I have 3 copies of the book, 3 paperback copies of the book to give away. So the first 3 people to tweet me on that username and say something like, I want a book, and bonus points for conference hashtag, can have one. Or I will also tweet a link to, there's a discount code to get an ebook from O'Reilly, and I think there's actually a free ebook from O'Reilly anyway, which you could, if you're interested in this book, you could use your voucher for that one. Thank you very much.